Welcome to another lesson in Math 8. Today we are in Unit 3, Lesson 13, and we are going to talk about more solutions to linear equations. Now, remember that a solution, when we're talking about a solution to a linear equation, this comes from the summary in Lesson 12, is that a solution to a linear equation with two variables is any pair of values x and y that make the equation true. When we see that, and we're talking about any pair that makes that true, that's going to mean that any ordered pair that we find that sits on the line will make the equation that we have for the line be a true equation. We're going to be working on how to figure those out. So today, what we're going to do with these coordinate pairs and what we're going to do with these equations here at the beginning is we have the opportunity to make up the x and the y. And I said, yeah, we do get to make these up. The cool thing about linear equations, if they are not a vertical line, it means that at some point they're going to pass through every single x coordinate and every single y coordinate at some point, as long as they're not a vertical line. So the neat thing about that is we get to choose some value for x, and that will fill in or help allow us to find the value for y. So let's think about this first one. It says for each equation, choose a value for x. So we're going to choose a value for x, and then we are going to solve to find the corresponding y. And this is an important word to use, corresponding value, because once we define what the value of x is, the value of y can be solved, and that's the only y coordinate that would ever be paired up with that x coordinate for this equation. When we think about the line 6x equals 7y, we see an equation here which will make a line. Let's say that I just want to make x equal to 1. Well, if x is equal to 1, then I can take the equation 6 times 1 is equal to 7 times what? Or 7 times y. And then my step would be for this one would just be simply to divide 6 would become equal to 7y, and if I divide by 7 on both expression, this simplifies 7/7 to 1, and I find out that y is equal to 6/7. Now I could try any other number I want for x. If we wanted to see another example for it, I'm going to go ahead and just use a lot of this space to going down here. Let's say if I wanted to know x equals 3. Then I would run through the same process and say 6 times 3 is equal to 7 times y. And then 6 times 3 I know is 18. 18 is equal to 7 times what? Divide by 7 on both sides. To simplify that value of y, and I find out that 18/7 is equal to y. So now I have an ordered pair here of 3 and 18/7. On the other one, it was an ordered pair of 1 and 6/7. Okay, let's go ahead and look at the next one. Let's pick a value for x. I'll go ahead and work on number 2 down over here. Let's pick a different value for x. Let's say x equals 4. And when x equals 4, I simply substitute 5 times 4 plus 3 times y equals 9. 5 times 4 is 20, plus 3 times y is 9. Subtract my value for 20 from both equations, or from both expressions, eliminating this one, and leaving us with 3 times y is equal to -11. Divide by 3 on both equations, or both expressions, and then I find out that y is equal to -11/3. So my ordered pair would be when x is equal to 4, my y has to be equal to -11/3 for this equation. Perhaps I want to try a different number. I can think of a number. I can try and guess and check on a lot of numbers. Or one number that I really like when we're in this form is I really like using 0. I like using 0 because you may recall when we talked about x and y intercept, when x equals 0, we're actually finding the y-intercept. And so that would mean plug in or substitute that value for 0 for x, plus 3 times y is equal to 9. And the cool thing about that is when I go ahead and substitute, that 5 times 0 eliminates the x, leaving us with just the y. So that'd be 3 times y equals 9, divided by 3 on both sides. Y is equal to 3. And the cool thing about that is I now know that the y-intercept for this equation is 0, 3. That's kind of cool to know that that's the y-intercept. I could also find what's called the x-intercept by simply doing the reverse order, substitute 0 for y. But since we're not doing that in this one, we'll have to do that one another time. Problem number 3. This one is a little trickier. This one has a fraction in it. But I have a strategy for you. Whenever I see a fraction inside of an equation, I can think about this. I can think about, especially when I have a coefficient for x, I can think about what number can I multiply by this fraction to give me a whole value, or at least an integer. And in this case, when we're talking about thirds, think about multiples of the denominator. Think about multiples of 3. So if I said, let's let x equal 3, I can go ahead and I can substitute that value right in there, and I'm going to say y plus 5 minus 1/3 of 3 is equal to 7. And then we simplify those values. Y plus 5 minus 1 is equal to 7. Y plus 4 is equal to 7. Subtract the 4 on each expression. Y equals 3. And so my ordered pair is going to be, when x is 3, y is 3. I could do the same thing for, I would choose maybe number 6 or number 9 or 12 or -3. I could use 0 to find the y-intercept. There's a lot of possibilities here that you can use. The bottom line is this. When we choose a value for x, we are setting the input and we can find its corresponding y value that would make the equation true. So when we talk about being true, we can tell that these ordered pairs, 1 and 6/7, 3 and 18/7, would be on the line that represents 6x is equal to 7y. And the ordered pairs here are going to be solutions for the equation for number 2. Number 3, the ordered pair 3, 3 would be a solution. You can try any numbers you want, but then it would be a good idea to go back and test those numbers. Something that might be a little bit simpler is when we actually look at graphs. And I know you're looking at this graph and you're saying that's not going to be simpler, but something kind of nice about a graph of an equation is we can actually look at the graph of an equation sometimes, and we can just tell right away that a solution won't work. And the way that we can do that is if that point or the ordered pair that we're working with does not appear on the line. So as we work through this, keep that in mind. So for each statement below, there's 3 different linear relationships here on this coordinate plane. And for each of the statements below, we are going to decide if the statement is true or false, but we have to explain our reasoning. And the reasoning will look very similar all the way through this. This one says the ordered pair 4, 0 is a solution to the equation for line M. As we look across here for the ordered pair 4, 0, we come across here 4 units. There's 2, there's 4. So 4 would be right along here. These little tick marks along here didn't copy too well, so I'm sorry, those are hard to see. So we're saying that there's an ordered pair right here where line M passes through. Well, that's not true because that ordered pair doesn't even show up on line M right here. And so we'd say, is 4, 0 a solution to the equation for line M? No. 4, 0 does not appear on the line. Now, it is a solution because it's there on the coordinate plane, but that point does not appear on the line itself. So it can't be considered a solution for line M. How about the coordinates of point G? So this one right here makes both the equation for line M and the equation for line N true. Well, here's line M and here's line N, and they intersect right here at point G. So in this case, yes, point G is, okay, we'll say yes over here just to make sure it's very clear. Point G is a solution for both lines M and N, because if you've already said it, you're right. It's because the point appears on the line. In this case, on both lines. And it actually appears on both lines at the same time. So we would say that the solution, one single solution, is in common for lines M and N. And that solution is point G. Unfortunately, I don't know exactly what that is because of where it's placed and there's no grid lines. How about when we say when x equals 0 is a solution for the equation for line N? Well, that might be tempting to say that because x equals 0 would be somewhere right here, but x equals 0 is anywhere along the y-axis. So what we have to consider with that is since it's anywhere along the y-axis, it's not enough information to know if it's really truly a solution. Remember when we talked about solutions to equations have to be an ordered pair of values that make the equation true. And since we're saying just x equals 0, this is not an ordered pair. So the answer is no, because x equals 0 is not an ordered pair. That means that we don't have an x and a y value to satisfy the equation that would be made for line N, which follows along here. If we had the ordered pair 0, 0, that would be a different story, but we don't. 2, 0 makes both the equation for line M and the equation for line N true. So the ordered pair 2, 0 right here makes the solution, or is a solution for line M and line N? Well, no, we already established that point G is the solution there. And point 2, 0, that's not even on the graph, or on the graph of these two lines, so it can't be true. No, the ordered pair 2, 0 does not appear to be a point or to be on either line. So it's not a solution at all. Is there no solution for the equation for line L that has y equals 0? So this is a little bit different question than number 3. It says there's no solution for the equation for line L that has y equals 0. When we talk about this line L, we look right across here with line L where the y coordinate would be equal to 0. Now remember that when we look at these coordinates, when we're talking about where the y coordinate equals to 0, that would have to be somewhere along the x-axis because we haven't done any kind of rise off of there. The line is continuing across the plane, but it does not cross the x-axis anywhere in this picture. However, at some point, since we see that that slope is increasing steadily over time, there would be some solution at some point where y would equals 0. So we could say yes, and it wouldn't be an actual solution, or it's a true or false statement. So there is no solution for the equation for line L that has y equal to 0. In this case, when we say that just simply y is equal to 0, thinking about that term, no, it's false. But at some point, the line will cross the x-axis. So I can't say yes or no because these are true or false statements. We would just simply say at some point, the line will have a coordinate of y equals 0, but y equals 0 is not a solution because it does not represent an ordered pair. So I don't mean to confuse anybody there, but I do want to make sure that we understand y equals 0 by itself is not a solution because it's not an ordered pair. But it is possible at some point line L up here will cross the x-axis and will make a coordinate equal to 0 of y equals 0. But this is still simply not enough information to make a solution for the line. All right. So a little bit more information, we're going to have to be flipping back and forth. The coordinates of point H are solutions to the equation for line L. Let's look at point H. I see that point H is on line L, so that definitely makes point H a solution to line L. True. Point H is located, maybe that's a better way to say it, on line L. There are exactly two solutions to the equation for line L. Exactly two solutions for line L. Well, we see here's a point right here, and here's a point right here. But is it possible that there's a lot more points that make up line L? Well, there's one, there's two, but what about the y-intercept? That makes a third one, and that automatically makes our statement false. So the reality is this: there's an infinite number of points that would make up line L, because this line continues to go on and on and on forever. So we would say this: there are exactly two solutions to the equation for line L. That's false. Meaning that there is any number of solutions for line L as long as they are on the line. Or as long as the order, I'm just going to put points, are on line L. Number 8, there is a point where coordinates make the equation of all three lines true. Remember this thing with all three lines true. We're talking about meaning one single point where all three lines intersect at the exact same place. Well, when we look at our graphs, we see an intersection right here of line L and N. This one is line L and M, and this one is line N and M. There is no place that all three lines intersect at the exact same spot. So we would say, no, this is false. There is no point where all three lines intersect at the same time or at the same point. All right. After you finish this discussion, the statements, it would be really cool if we could do this in a group work, but it doesn't look like that's going to be the way we can do it. The next section here talks about, I'll take an X please, meaning that we would have some partners here and we would go through and do some work with that. Again, given the nature of our class, we're just not going to be able to do that. So that's really it for our lesson today. When we talk about, in summary, we talk about solutions to linear equations. Remember, I would go back to this answer here that says a solution to linear equations with two variables is any pair of values x and y that make the equation true, meaning that the solution has to fall on the line of the graph in order to be true, and that single point will also make the equation for the graph true at the same time, meaning that both expressions will be truly equal to each other. When we think about an equation such as this one, 2x minus 4y equals 12, if we know that 0, -3 is a solution to this equation, then we know that 0, -3 is a point on that graph of the equation. Since the point on the y-axis, we know, or since it's a point on the y-axis, we know this is a y-intercept for the graph. But what about the coordinates of the horizontal intercept? Meaning, what happens if y equals 0? Well, that means we can find the x-intercept. So we're talking about doing an introduction here of a horizontal intercept and a vertical intercept. And the coolest thing about this, I like to look at this in a table when I do this, because sometimes it helps me to see it a little bit better. And I'm only going to be looking for two ordered pairs. I'm going to be looking for when x equals 0, this one up here would be my y-intercept when I'm trying to find out what y is. And when y equals 0, I'm trying to find my x-intercept. I use that same equation 2 times x minus 4 times y equals 12. And then I substitute the 0 for x. 2 times 0 minus 4 times y is equal to 12. And then I have this super fancy method that I call the cover-up. 2 times 0 is 0. And so if I cover that up, it's eliminated. And I'm left with the minus 4 times y is equal to 12. If I divide both expressions by negative 4, I find out a y is equal to 12 divided by negative 4, or a solution of negative 3. And so that y-intercept right there, I forgot a column that I like to put on here, would be my solution. My solution is 0, negative 3. The x-intercept, when we substitute that, we do the same thing, except this time we have 2 times x minus 4 times 0 is equal to 12. And now this one I have to eliminate by covering up the y, because it's being multiplied by 0. And I'm left with just simply the x. And I find out that x is equal to 12 halves, or 12 divided by 2, which means that x is 6, and my solution pair is 6, 0, or what we call the x-intercept. This is a really neat strategy for finding the x and y-intercept, to find out where the line crosses both the x and y axes. And it's a really easy way to make the lines. It's also a way that we find a lot of different solutions to real life problems that are actually being solved with this kind of work. So by starting with one value, we can always find the other value. I think that's probably one of the coolest statements that we can ever get with this. We can always find solutions to the equation by starting with one value and then solving with the other value. And the coolest part is that I can pick one of those values and I can find the other one. So give that a shot. Let me know how I can be of help. There is a video that goes with the homework. Keep working forward. Don't you dare give up. Have a great day.